In this video, we're asked to write a method called trimEnds that'll be added to the linked int_list class. The method accepts an integer parameter k, and it'll remove k elements from the front and the back of the list. So for example, say we have the following list that goes up by 10 each time we pass a node. Pardon me. So it goes 10, 20, 30, all the way up to 110. If we call 3 on it, it should remove the 10, 20, and 30, and the 90, 100, and 110, and leave us with this list here. And then if we decide to call the method again with the parameter 1, it'll remove the 40 and the 80 and leave us with a 50, 60, and 70. So we do know that we're going to be dealing with a type void because we're changing the list and not returning anything that's new. If the list is not large enough to hold k elements, so if our size is less than 2k, then we're going to throw an illegal argument exception. If it contains exactly 2k elements, it should return an empty list. And if k or 0 is negative, then the list should remain the same. We have access to the front of the list here, and we have access to the data fields and the next fields of each one of the nodes. So let's get started. To meet public void, trimEnds. It's going to take in the parameter k. So at this point, how are we actually going to get through the size of the list? Well, we need to count the size first. And the way we're going to do that is we're going to set a counter variable to 0, and we're going to say, okay, while, oh, no, we can't actually do that yet without modifying the list. We need to create the reference node. Yeah, because otherwise if we set it to front and we said, okay, well, there's, while front is not equal to null, let's progress through the list. What'll happen at the end is, we'll get a count of how many variables were in the list, but what'll end up happening is we'll have changed the list so that there's nothing in it. So what we're going to do now is we're going to set a while loop, while current is not equivalent to null. We want to progress through the list, and while we're doing this, we want to increment our count by 1 each time. Okay, so at this point, we have the size of the list. So that's good. The first test we wanted to do was we wanted to see if the size was less than 2 times the k value. Why 2 times k? Because we're removing k elements from the front and the very back of the list. So if the size was less than this, meaning we have more things that we want to remove than what we actually have, let's check the spec here. If the list is not large enough, we'll throw an illegal argument exception. So at this point, we'll throw new illegal argument exception because they're telling us to do something that we possibly can't do because we don't have enough elements. The next test was to see as to whether or not the size was exactly equivalent to 2k elements. And if it is, at this point, what we want to do is we want to return an empty list. And remember, you can think of the nodes attached as like little balloons. So if you cut the very base string of the whole attachment of the balloons, all the balloons will fall off. So the way we do that is just saying front is equivalent to null. Front will be pointing at null. We'll lose all of the other node values, and that's exactly what we want. The other case is, okay, we do have k elements to look at. So what do we want to do? Well, the easiest case is to deal with the front. So we're going to start with that and remove k elements from, well, k nodes from the front. The way we're going to do that is we're going to say, okay, we need a counter here. And what we're going to do is we're going to say, while our counter is less than the k parameter itself, then what we want to do is we want to start setting our front value to be front.next so that we can skip over those k elements. And of course, when we do this, we want to make sure that we eventually break out of the while loop, so we need to increment our counter each time. Okay, so we've dealt with the front case. Now, the next part is we need to get to the back. So how are we going to do this? We need to skip the middle, because we don't want to remove any of the middle elements. So how are we going to move through the middle here? Well, we're going to say, okay, did we set it? Yeah, okay. So we can use our current up here that we used before, and we can just reset the current to our new front value here. Why? Because the front is now skipped over the k elements that were originally at the front and is moved on to the first middle element. So that's fine. So what do we want to do from this point? We want to say, okay, while our count is less than the size of our whole thing, -1 to get the very last node. And then we need to subtract k, because we the reason we subtract k is because we want to go back k elements so that we can get the bounds for the middle segment of our list. So we want to say, okay, while that's happening, we just want to go through this list and have our current kind of pointing to the next variable and keep on moving. And what are we going to do to break out of this loop? Well, we need to increment the count by 1 each time. Okay, so now at this point, we've passed the middle section, and now we're dealing with the end case here. So how are we going to do this? We're going to do the same thing we did up in this case, where we cut the first string and we let go of the rest of the balloons. So at this point, what we can say is okay, so the next field, or the next node we're going to have is going to be a null value, and that'll just get rid of the other nodes at the very end of the list. And that's it for this assignment.